Welcome once again to Fundamentals of Public Policy Analysis. In the preceding lecture, I discussed about the economic risks associated with public infrastructure projects. I also introduced the social cost benefit analysis. In this lecture, you will study in detail social cost benefit analysis. It is an evaluation tool that assesses the broader societal and economic impact of a project, policy, or investment. It is an economic evaluation method used to assess the total impact of a project or a policy or investment on society as a whole. It identifies all impacts, monetizes costs and benefits, and convert all future cost and benefits in present value, and then cost benefit ratio is estimated, and decision rule is that if benefits of a particular project outweighs the cost, then the project will be economically viable and sustainable because the society is getting more benefits from the project than what the society is bearing in the form of cost. Private investors, they also prepare DPR, and in DPR they also estimate cost benefits of the projects to know whether project will be economically viable and how many years will be taken to make the project at the break even and start earning profit. But social cost benefit analysis is different from private cost benefit analysis because in private cost benefit analysis, private investors, they take into account only the internal cost and benefits. Internal cost may be direct cost or indirect cost, and internal benefits means how much revenue generated, how much will be profit, etc. All these are taken into consideration while preparing the cost benefit analysis. Internal rate of return is calculated, CB ratio is calculated, net present value of the project is also calculated. So, all these exercises are also done by the private investors. But when we talk about public investments, especially in context of infrastructure or social welfare projects, then we also take into consideration not only the cost that is directly associated with the commissioning of the project, but we also take into account the social cost. And social cost means how much the society in terms of benefits or welfare is getting and how much society is bearing in terms of cost are taken into account. So, briefly I can tell you that in cost benefit analysis, externality is one of the important cost which is also added. Means when we include the external benefits and external cost on the society with private cost and private benefits, then it becomes social cost and social benefits here. And simple decision criteria is that if total benefits from a particular project exceeds the total cost, then project is economically viable, and we can have alternative projects, and based on the IRR, cost benefit ratio, which projects have higher IRR, higher cost benefit ratio, they will be preferred or given priority in the selection as compared to those who have less benefit cost ratio or less internal rate of return. There are few steps that are taken while making the cost benefit analysis. First is defining project objective and economic rationale. So, first we have to define clearly what is the objectives of the project. means whether objective is to reduce poverty, inequality, or whether the project objective is to provide clean air, clean water, clean environment. So, all these infrastructure projects or provide clean energy like Ujjwala Yojana or access to clean water. All these objectives must be clearly defined, and the rationale for having such project, why this project is required. So, economic rationale is to be mentioned. Then second step is forecasting effective demand for project outcomes. So, demand projection is to be made, how much will be the demand in different years and how much will be the life of the project. So, based on all these parameters, we can assess whether the benefits of the project will be higher than the cost of the project. Then determining whether benefit exceed cost, assessment of sustainability of net benefits throughout the life of the project. The benefits and cost of the project will occur over a longer period. So, therefore, we have to see whether project will be sustainable in a longer time horizon. Then testing for risk associated with the project, we have already discussed in the preceding lecture that there are many risks of the project. So, in cost benefit analysis, we have to also identify what will be the associated risk of the project and how to examine these risks and how to address these risks in the project. Then identifying the distributional effect of the project. This is also very important. Who is going to get benefit from the project and who is going to bear the cost. So, the people who are bearing the cost of the project may not be the same set of people who will get the benefit. So, we have to clearly understand who is going to bear the cost of the project and who is going to get the benefit of the project, or how the benefits of the project and cost of the project will be distributed across different section of the society. These aspects are also taken into consideration while preparing the cost benefit analysis for any public project. When we apply cost benefit analysis in public infrastructure projects, there are few critical issues on which some understanding is required. First is aggregation over goods. Aggregation over goods means that project provides several benefits. Some may be direct benefits, some may be indirect benefits, or you can also say there may be multiple goods are provided by the projects. So, how to aggregate them in a single monetary value? This is one important issue, and in that case shadow pricing method is used, because the market price of the product may not actually reflect the true cost of the product or services. So, therefore, shadow price method is used in case of social cost benefit analysis. So, let you know what is a shadow price. A shadow price is a proxy value assigned to a good or service or resource when its value in true sense is not accurately reflected in the actual market price. So, if true value of a product, good or resource is not reflected by the economic value determined or by the market, then a shadow price method is used. Why it is not reflected? Because market price is distorted by taxation, subsidies, minimum wages, laws. So, they actually distort the market price. There may be market failures due to the fact that price mechanism may not freely work due to government interventions in terms of taxes, subsidies, or rising agriculture wage rate or industrial wage rate above the market wage rate, so they will distort the market. Another important is externality, because externality means unintentional harm or benefit received by a person not directly involved in the activities. For example, if you are driving a car on the road and you are enjoying the car, you have the right to drive the car on the road, but if smoke released by your car is harming the person who is walking on the road, and his health is affected, he will go to the doctor and pay some money. So this extra money is actually the external cost imposed on that person due to your right to run car on road. So market failure and externalities, these are the two important things why the shadow pricing is required to calculate or aggregate the value of goods or services of different natures created by a particular infrastructure project. And here the real value is calculated by considering the opportunity cost. So opportunity cost is very, very important, and that is taken into consideration while estimating the shadow pricing. Second issue is aggregating over time. As I discussed earlier, that benefits and costs of infrastructure projects will be received by the society over a longer time. So, how to aggregate future costs and future benefits and convert them at the present value is also a big challenge in social cost benefit analysis. In this case, discount rate is used to discount the future cost and benefit of the project, and how this discount rate is determined, that depend upon many factors. How much is the cost of borrowing funds, and sometimes a high discount rate make the infrastructure projects or social welfare related projects economically unviable, and therefore an appropriate discount rate is necessary to make the project economically viable. Sometimes some big Watson projects are funded by soft loan taken from World Bank. So in that case, discount rate can be kept at low level. So discount rate is very, very important, because entire project outcome depend upon how much is the discount rate taken by the developer while preparing the cost benefit analysis. Then third is aggregation over people. Very interesting things, that how the benefits, because benefits and cost of the project are shared by many people of different socio-economic backgrounds. So how to aggregate these benefits over people? In this regard, equity principles should be followed, and more weights should be given to those projects which benefit the poor people, marginalized group, common people, rather than providing the benefit to rich or middle or upper middle class households. And it make economic sense, because marginal utility of money varies across income groups. For example, 10 rupee note in a pocket of poor people is not same as the same note in the pocket of a rich person, because marginal utility of money for poor people is much higher as compared to the rich people. And in this case, one important criteria suggested by Caldor Hisk is that a social cost benefit analysis operates on a criteria set by Caldor and Hisk efficiency, and that is, a project is good if its benefits outweigh the cost, regardless who get the benefit and who bear the cost. So this is the problem, major problem, because when we talk about efficiency, in fact, you should understand efficiency and equity. So cost benefit analysis actually discuss about efficiency, because when we talk about the cost and benefits and if benefits exceed the cost, we accept the project. But whose benefit, whose cost, that is also important. And in this criteria and Pareto optimality criteria is also used, and all these criteria for selection of the project is solely based on efficiency. Higher the efficiency, better is the selection of the project. But they actually ignore the equity, and equity is very important. Means if a particular project is benefiting more to the poor people than the rich people, then such kind of projects will be considered more equitous. But if a project is targeted to give more benefit to rich people, then it will not be considered as a socially desirable project, because social welfare will be maximized when the maximum weight is given to the poor people in the benefit sharing of infrastructure projects. So, this is one important issue of aggregation. Means there is a issue not only of efficiency but also of equity. Then another, in addition to these three key issues, aggregation over goods, aggregation over time, and aggregation over people, there are some other associated issues related to cost benefit analysis, and we had to understand them also, like environmental perspective of cost benefit analysis. Like few issues need additional attentions, for example recreation demand and willingness to pay, loss of forest area, biodiversity, distributional issues. So we have to also see the impact of the infrastructure project on environment, biodiversity, loss of forest area, and loss to the displaced people, etc. So, environmental issues are equally important while preparing the cost benefit analysis. Then, cost benefit analysis focuses on efficiency and fail to include equity and distributional aspect. This point I already raised. So, this is also important. Then, dealing with risk and uncertainty. So, when we make infrastructure projects, they also face risk and uncertainty. So, dealing with risk and uncertainty is also important issue, because what happens in future, it is very difficult to predict, and sometimes some policy changes, regulation changes, and they also affect the project outcomes. I can give a simple example, although it is not directly related to infrastructure project, but look at the banning of diesel operated car after 10 years. So, if company has made huge investment, or a consumer has made huge investment in buying a car, and after 10 years if it is not working due to regulation, then it will be a great loss. But no one can predict that such kind of regulation will come after sometimes when you purchase a particular product. So, same things happened in case of other infrastructure project. For example, if a power project is constructed like hydropower project, but in coming future, if solar energy or some other form of energy becomes more cheaper than the hydropower, then the project economic viability may be affected. So, these may be different risk of project, but one thing you should know, that when a project is prepared and DPR is prepared, risk analysis is done, but uncertainty cannot be quantified, risk can be calculated, and this is the way how insurance companies, they fix the premium of different policies based on the associated risk, but uncertainty cannot be quantified, and sometimes the uncertainty of future events may also affect the project outcome. Let me now discuss the theoretical foundation of social cost benefit analysis. Benefits are defined as increase in human well-being or utility. So when a person is getting benefit from the project, his or her welfare or utility will increase. But when the cost is imposed on a person, then there will be disutility or welfare of the person will reduce. So cost reduces the welfare of the people and benefit improves the welfare of the people. This is a simple theory. For a project to qualify, its benefit must exceed the cost to be borne by the society. And here there are two basic aggregation rules. First is aggregating benefit across different social groups involving summing of willingness to pay. This is one important concept, willingness to pay for getting the benefit or willingness to accept as compensation when your welfare is lost. For example, when a project is set up, people will be displaced, their livelihood will be affected. So, in that case, how much they are willing to accept as compensation, that is called WTA, willingness to accept compensation. So, these are the two scenarios. One is willingness to pay and other is willingness to accept as compensation. Higher weight should be given to benefits and costs accruing to disadvantaged or low income groups because marginal utility of income is higher for such groups. Further, aggregating over time involve discounting. I discussed it earlier in the issues associated with cost benefit analysis. Discounted future benefit and costs are known as present values. Here, the concept of willingness to pay and willingness to accept are firmly grounded in welfare economics and correspond to the concept of compensated variation and equivalent variation. Compensated variation means when the price of a particular product increases, then the utility will decline for the consumers. So, in that case, consumers may be given additional income to keep the utility constant. So, second concept is equivalent variation. In case of equivalent variation, if the utility of a person is to be shipped from the initial level to the new level, there may be two ways. One, the government can improve the quantity or reduce the price to make person reach to the higher level of utility, or there may be another options that there is no change in the price or goods quantity to be applicable to the consumer, but a compensation is directly given or additional income is given so that consumer may reach from the initial level of utility to the new level of utility. So, the basic difference is in case of compensating variation, if the price is increased or decreased, then accordingly the income will be reduced or income will be increased to keep the utility constant. But in case of equivalent variation, consumer reaches from initial level of utility to the higher level of utility with the change in price or quantity or without the change in price or quantity by giving direct amount to the consumer to make him reach to the new level of utility. Then there are stages of social cost benefit analysis. First, we have to ask the question what project is being evaluated, what alternatives are there, identifying the physical impact of the project, then valuing the impact of the project, putting discount rate and getting the future cost and benefit at the present value. So, applying the net present value test and then conducting the sensitivity analysis. So, first is social discount rate. This is the rate used to convert future flows of cost and benefit from the project into the same unit at current values or present values. And SDR, we can use this social discount rate to calculate the net present values. And for example, if I is 2%, 0.02, then the present value of 1 rupee available in the 10th year will be 82 paisa. That will be, simple formula is 1 plus I raised to the power minus t. So a positive discount rate decreases the weight for the income accruing as the time passes. As for the project selection, a high SDR would favor projects yielding immediately net benefits, while a low social discount rate may favor the project with net benefit accruing over a longer period. So, if especially in context of infrastructure project, since its benefit accrue over a longer periods, so social discount rate should be kept at low level. So, this is a table you can easily know how the discount rate set affect the present value of future cost and benefit. For example, here 1 rupee at the 2% discount rate becomes 0.138 rupees after 100 years, and if discount rate is increased, then it becomes 0.0076, and if 10% discount rate is fixed, then it becomes 0.000073, and if 15% is kept as discount rate, then 1 rupee of today becomes almost 0 in 100 years converted at the present value. So, keeping discount rate is very, very important. How to set the discount rate for the project? Generally, it is set based on the cost of borrowing funds. Sometimes rate of interest is considered as the discount rate, but for large infrastructure projects funded by soft loan should have less discount rate. This is the formula for calculating net present value, that is sigma T to 1 to n. CF means cash flow, means benefit, and C0 means cash outflow, means cost. K is discount rate, and now the total discounted sum of benefits minus total sum of discounted cost is equal to net present value. And here you can also know internal rate of return. Internal rate of return is the rate at which the net present value becomes 0. So, a rate at which the net present value becomes 0, or you can say that the project is neither getting loss nor profit, or you can say at this rate project is break even. Here R is internal rate of return, CF is cash flow at different time periods, and CO is cash outflow or cost at different time period. IRR is the maximum interest rate a project could pay for resources to recover its investment and operating cost and still break even. So, this is the highest rate that the project can pay as an interest rate and still break even. So you can understand that internal rate of return is closely associated with cost of borrowing funds, and if cost of borrowing funds in terms of interest rate is lower than IRR, then the project will be economically viable. So, it indicates the project's earning capabilities. How much is the earning capability of the project, that is known through IRR. The selection criteria in this regard is, if we have say A, B, C, D, these are the different projects available. So, based on IRR, if IRR is 15, 12, 10, 8, so we can rank all the project on the basis of IRR, and the project which has the highest IRR, that will be given priority in the selection, because that project provide more returns over a period of time as compared to cost. Let me also discuss benefit cost ratio. Benefit cost ratio is the present value of cash outflow as well as inflow. So, a ratio of present value of inflow divided by present value of outflow is benefit cost ratio, and if it is equal to BCR is equal to 1, then cost of the project is equal to benefits and project is not earning any profit. So, BCR must be greater than 1 in order to generate profit. Higher the BCR, better is the earning capability of the project. Let me explain this by taking a simple example. Let us consider a construction of a dam for electricity generation, and construction time is 2 years and operating life of the project is 18 years. So, it means that project will be eliminated after 18 years or will not generate profit. So, life of the project is 18 years. Assume that total construction cost is 1.1 billion rupees, and the cost is equally spread in 2 years, means half of 1.5 million means 55 lakh will be spent in first years and 55 lakh will be spent in next years, and project will be completed in 2 years. Operating cost of the project is rupees 50,000 for each year over the operating life of 18 years, and this is the output. You can see 50 lakhs kWh per year is the output of power generation, and rupees 0.05 is the cost or price of that output. Assume that electricity so generated provides savings of 0.02 per kWh compared to the next best method. We can estimate the cost and benefit analysis of the dam project. In addition to the power generation, it also provides benefit to the tourist in terms of recreation, and we are estimating that 50,000 person will visit the site, and 1 rupee per person will be spent, so or benefit received by the project. So, in this way we can also assume that there is no inflation, cost and benefit are known with certainty, there is no uncertainty in this, then we can calculate the cost and benefit, and this table clearly tell us that in first years 55 lakh spent, then in second year 55 lakh spent and project become complete by 2 years, and here these during these 2 years there is no benefit, only cost, and total cost is 55 in first year, 55 lakh in second year, and benefit is negative because it is loss. So, net benefit is minus 55 lakh, 55 lakh, and here in third year the project start providing output, and operating cost is 50,000, and benefit in terms of recreation at the rate of 1 rupee is 50,000, and electricity revenue generated is 100,000. So, in this way 150,000 is the benefit and operating cost is only 50,000. So, net benefit received by the project is 100, and now it will carry on up to 18 years, and in this way you can calculate the project's cost and benefits, and when you apply the formula of cost and benefit analysis, then you will find that if you use 10% social discount rate, then net present value of benefit is about minus 5 lakh 9,335. This is actually the loss. So, the project is generating loss if discount rate is 10%, but if discount rate is 5%, then it will generate profit 39,485. It means that the project can be economically viable only when the discount rate is kept 5%, and when you calculate IRR, internal rate of return, then it will comes 5.4%. It means that internal rate of return is higher than discount rate. So, project is economically viable only when the discount rate is 5%. So, one important inferences which we can draw from this analysis is that project viability depends upon how much social discount rate is kept in the analysis. Then we can also do sensitivity analysis. Sensitivity analysis can be used to assess the effects of changes in the project variables that are quantified. It examines how the net present value and IRR change with the change made in some variables. So, we can make change in several variables. So, how the change in the variable is affecting the project outcome. For example, I already discussed that if discount rate is kept 10%, then project is running in loss. If discount rate is kept at 5%, the project become economically viable. Similarly, we can also factor in the interest rate and many other macroeconomic parameters to know how these macroeconomic parameters are affecting the outcome of the project. So, sensitivity analysis can be done by keeping different values for discount rate, or we can also know how much will be the inflation rate, or how the macroeconomic factors changes, and how the change in these variables affect the outcome. So, let me now also briefly discuss a case study on cost benefit analysis of watershed development project. This project was empirically commissioned by me some years ago. So, this portion is taken from that projects. We conducted cost benefit analysis of a large number of projects, 50 watershed development projects in Uttar Pradesh, and we collected the primary data, and based on the primary data we estimated the cost benefit analysis, internal rate of returns. Here the main objective of the watershed development project is to reduce poverty, improve livelihood conditions, improve common property resources, conversion of non agricultural land into agricultural land, create alternative livelihood options to the poor people, and benefits of such projects are both tangible and non tangible. Non tangible means water table will go up, vegetation will go up, and primary data we collected from 50 watershed in 11 districts of Uttar Pradesh, and sample size was 3750 farmers. We collected data from 75 farmers from each watershed. We kept different social discount rate 5% and 10% to know how the project will be economically viable or not. Another important aspect is because the lifespan of the project was 5 years, so we also projected how much will be the agriculture growth rate during the 5 years, and taking different scenarios we know how much is the cost benefit analysis and internal rate of return from the project. Initial investment made by Ministry of Rural Development on watershed was 6,000 rupees per hectare, that was spread across 5 years, 15% first year, 30%, 30%, 15 and 10 in the remaining years. So, the allocation was made during the 5 years, and based on this data and collecting income from agriculture, from the farmers and some other tangible, non tangible benefits, we calculated the cost benefit analysis, and this is the table. These are the district: Auraiya, Banda, Hamirpur, Jalon, Jhansi, Kannauj, Kosambi, Lalitpur, Moba, Muzaffarnagar and Saharanpur, and then these are the values with the assumption of 2% rise in incremental income per annum, and based on this we calculate net present value, benefit cost ratio, and then IRR. So you should also understand that the project viability or cost and benefits from the project depend upon how much is SDR, that is social discount rate. But IRR is independent of SDR. You should understand that internal rate of return will not depend how much is the discount rate, but discount rate affect the cost benefit ratio, and in all the districts we have shown that if discount rate is 5%, then cost benefit ratio is, say in case of Oreya, 1.58, but when discount rate is 10%, then this cost benefit ratio declined to 1.51. Then we also prepare the cost benefit ratio if agriculture grows at the rate of 3% per annum, then the output will increase, and that will also affect the cost benefit ratio and IRR. So IRR also depend upon how much is the incremental growth in the income of the farmers. This is in continuation of the same. We just take here 4% growth rate in the income per annum of the farmer, then 5%. So we created a scenario by taking 2%, 3%, 4%, 5%. We have included 5 up to 5% because as per our experience, more or less agriculture growth rate in India is growing at the rate of 3 to 4% on an average in real term. So taking these growth rates and to social discount rate, we compare the districts in terms of their net present value as well as benefit cost ratio, and we also calculate IRR, internal rate of return, and we find that internal rate of return in across all is much higher than the rate of interest. It means that Watershed development programs has been quite successful in raising the income and livelihood of the farmers. Let me now sum up this topic. In this topic, I discuss steps for project appraisal. I also explain what makes infrastructure project different from other projects. I also examined several economic risks associated with the large development projects. Key issues I discuss in this topic are cost overrun and benefit shortfall because of technical, psychological, political, economic reasons, rent seeking behavior of the person involved in the project preparation, delusion and deception of the developers in forecasting the project outcomes, and involvement of multi stakeholders. Social cost benefit analysis was also discussed, and in fact there are three key issues related to application of social cost benefit analysis in large infrastructure project. First is aggregation over goods, because there may be different type of goods or services created by the project. How to convert them in monetary value is a big challenge, and here the researchers use shadow prices because the market price cannot capture the true cost and benefit of such projects. So shadow pricing, which include the opportunity cost of the resources, are taken into consideration to estimate the cost and benefit. Then second issue I discuss in detail is aggregation over time, because the benefits and cost of infrastructure projects spread over a longer period, and it becomes a very difficult how to convert future cost and benefits in the present value. And in this regard, you have stated that social discount rate is used to convert the future cost and benefit at the present values, and after getting the present value of cost and benefit, we apply benefit cost ratio, and if benefit cost ratio is greater than 1, then project is economically viable. And when you have alternative projects, those projects which have higher benefit cost ratio must be given priority in the selections. We also discuss another important issue, and that is aggregation over people. And as I discuss in this lecture, that cost benefit analysis is purely based on efficiency criteria, and quite often ignore the equity. So, equity is equally important, and when the cost benefit analysis is done, more weight should be given to the benefits which are to be received by the common masses or poor people or marginalized people. Then I also discuss a case study of the cost benefit analysis applied to watershed development project. And in the last, let me conclude this topic by focusing on 5 key points, or you can say 5 roadblocks to infrastructure projects. First, land acquisition. This is one issue. Second is regulatory framework. Third is delays in clearance and implementation of the project. And fourth is slack capacity. This happens especially in project like road. It has been observed in Yamuna Expressway quite sometimes that the full capacity was not utilized, but after linking of Yamuna Expressway with Lucknow Expressway or to Bombay Expressway, then traffic flow to that road also improved, and now project becomes more and more economically promising. But inefficient pricing, how the pricing or tolls on especially in case of road is fixed, all these are the important issues, especially when the large infrastructure projects are set up under public private partnership. So these are some of the important issues you can think of. That's all. Thank you very much.